Students, now let's begin one last type of questions. In this, you have questions which are based on k raised to x into sine bx plus c or cos bx plus c, and then you'll be having powers of sine and cos also. Now, if I take a question in which a power of sine and cos is involved, you will be definitely able to solve the question when the power is not involved, isn't it, students? So I'm going to solve one of the questions from the third and the fourth, so you can give a try to the rest of the two questions. Now remember, this 3 raised to 2x is actually 3 square raised to x. There is a property that you already have learned in law of indices. It says a raised to m whole raised to n is a raised to m into n. So this is a very important property that I'll be using to solve this particular question. 3 raised to 2 whole raised to x is what is going to get transformed of 3 raised to 2x. So I get 9 raised to x here. Now students, I'll be solving one question from here, either the third one or the fourth one. I guess third one is more important because here both the terms are having a power, sine square and cos cube. So I'll be solving the third question. So now before I proceed with the question, you need to very quickly revise your formula. The formula is for y is equal to k raised to x into sine bx plus c and y is equal to k raised to x cos bx plus c. So let's first of all write the formula for y is equal to k raised to x sine bx plus c. So you must be recalling that the nth order derivative yn comes out to be again r raised to n. Then you have k raised to x sine of bx plus c plus n phi. I need to clearly specify the values of r and phi over here. So that can be easily written. So let's write it in a short while from now. We will write the formula for the other standard form y is equal to k raised to x into cos bx plus c, because there also r and phi are going to get involved and both the places r and phi will have the exact same value. So students, that is one of the formulas of the two standard forms. The second standard form is y is equal to k raised to x into cos of bx plus c. So you get yn is equal to r raised to n k raised to x cos of bx plus c plus n phi. So in both the places you are going to tell the value of r and phi. So you must be recalling r was actually under root of a square plus b square in the previous formula. Here the value of a is taken by log k. We have seen the derivations for both the formulas. Students, you got to remember your formulas. So here I'm going to get here log k the whole square plus b square, that's the value of r, and you must be recalling that theta or phi is given by tan inverse of b upon a. So here phi is going to be tan inverse of b upon a is log k. So b upon log k is what I'll be getting. So that's the value of r and phi. So these are the two formulas, students. Now we are in a position to begin with the third question. So let's start the third question. In the third question, you have y is equal to 2 raised to x, sine square x and cos cube x. Now, you should always try to bring the powers of all the terms same. So my question is y is equal to 2 raised to x into sine square x into cos cube x. So can I write this cos cube x as cos square x into cos x? So students, you know the steps, isn't it? Because we have seen questions where the powers of the trigonometric terms were involved. So it is exactly going to be same. The only additional term here is 2 raised to x. That's why the formula will change. So rest of the steps are exactly going to be same. So you maintain the same power for both the terms. So cos cube x can be brought down to square. Square cannot be brought up to cos cube, isn't it? So cube getting is slightly difficult from square, but getting a square from a cube is quite easy. So this cube I'm going to transform into square. So I write y is equal to 2 raised to x sine square x into this cos cube x now can be written as cos square x into cos x. Now you can take these two terms sine square x and cos square x together, both have the same power 2. So I can write y is equal to 2 raised to x. Inside the bracket I will write sine x into cos x the whole square and then you have cos x. Now students, you can easily understand this is sin x into cos x. You have seen this formula multiple number of times now. The formula for sin 2x is 2 sin x into cos x. There is sin x into cos x. What I need more is 2. So I'm going to get 2 over there inside the bracket. So I can write 1 by 2 and 2, isn't it? Inside the bracket. This is very important. Whatever adjustment is done inside the bracket. So I get now 1 by 4 because I'm going to do the square of this 1 by 2. It has a square, so it becomes 1 by 4, and since it's a constant, it is written at the beginning. Then 1 by 4, 2 raised to x into what is going to happen to this 2 sin x into cos x. So we know that 2 sin x into cos x is sin 2x, and its square, it becomes sin square 2x into you have cos x. Now students, you must be recalling your half angle formulas. Again, this sin square 2x, I'm going to make use of the half angle formula. 1 minus cos 2x is 2 sin square x. You must be recalling this formula, isn't it? So you have sin square 2x, isn't it? Sin square in place of x, there is 2x. So this is again a half angle. So this 2x here gives me 4x in the term of cos. You should be very attentive while using the half angle formulas. And what is missing? The 2 is also missing. So I'm going to get that 2. So let's multiply and divide by 2. So I get there is already a 1 by 4. I am multiplying and dividing by 2. So there is 1 by 2 here. Then you have this 2 raised to x. Then you have 2 sin square 2x, and finally there is a term of cos x. So what happens to this 2 sin square 2x? Be very careful when you tell the answer. 2 sin square 2x is going to be 1 minus cos 4x. Half angle formula, students. So outside I get 1 by 8. Then I have 2 raised to x, and the formula for 2 sin square 2x, it is 1 minus cos 4x into cos x. So now what I can do here is, in the next step, I'm going to open the bracket. Now be very careful, the bracket is going to get opened from two sides, from the left as well as from the right. So both the terms are going to get multiplied inside the bracket. So make sure that you maintain brackets very properly. So I get 1 by 8. I put up a bracket over here. I begin with the bracket. So 2 raised to x multiplies with 1. You get 2 raised to x. Cos x multiplies with 1. You get cos x. So my first term is simply going to be 2 raised to x into cos x. Now this definitely looks like k raised to x cos of bx plus c. The value of c is 0. The value of b is 1. And the value of k is 2, isn't it? The value of k is 2. So that's 2 raised to x into cos x. Look at the next term that you are going to get. You are going to get a negative sign. Then 2 raised to x multiplies with cos 4x. Cos x also multiplies with cos 4x. The largest angle is 4x. So cos 4x will be written at the beginning, and then it will be followed with cos x. So I get here 2 raised to x cos 4x into cos x. Now I certainly want to change this cos 4x into cos x, isn't it? This cos 4x into cos x can be simply changed into cos. You have something called as a de-factorisation formula. Let's make use of the de-factorisation formula, but you remember that it will need a 2. So 2 cos A cos B. So what I need to do is I need to multiply and divide by 2 only to this particular term. I need not change this first term over here. So is it okay to now write it like this? 1 upon 8 2 raised to x cos x minus 1 upon it into this term, and this again needs a 2. So I'm going to multiply and divide by 2 over here. I write 1 by 2. Then there is a 2 raised to x, and I'm going to bring a 2, and I have this cos 4x into cos x. You can easily understand what is going to happen to this term, 2 cos 4x into cos x. Now, you should be extra careful, students. There is a negative sign, there is a constant, there is a 2 raised to x, and then you are going to replace few things with this particular term. So you always take care of the terms that's what's happening over there with the terms over there. So 1 by 8, 2 raised to x cos x, that's my first term. Nothing happens to that. So 1 by 8, you have 2 raised to x into cos x, then minus this 1 by 8 into 1 by 2 is 1 by 16, and then students 2 raised to x, and you are going to make use of the formula 2 cos A cos B. So what's the de-factorisation formula? Very quickly remember in your mind, it is cos A plus B plus cos a minus b. So cos 4x into cos x gives me cos 5x plus cos 3x. So let's use a bracket and write the formula for 2 cos a cos b, cos a plus b. So that's cos 5x plus cos a minus b, so cos 3x it is. Now outside you can see that 2 raised to x is present, 1 by 16 is present, you can multiply inside the bracket. So my final step before I use the nth order derivative is the first term 1 by 8 2 raised to x cos x, the next term minus 1 by 16 2 raised to x into cos 5x. The next term is going to be negative because outside the bracket a negative sign is present. It will change all the signs present inside the bracket of all the terms. So plus becomes minus. So minus 1 by 16 and 2 raised to x cos of 3x, isn't it? Now there are 3 different terms, students, 3 different terms, and everywhere k is same, but the value of b is different, 1 5 3. So here I will need r1 5 1, r2 5 2, r3 5 3. This has to be always remembered. What are the values of r and phi? You need to specify them. So I'm going to differentiate n times. So let's differentiate n times, isn't it, students? So if I differentiate n times, I'm going to get yn is equal to, so nothing happens to 1 upon 8, it remains constant. Then this is k raised to x into cos of bx plus c. So c is 0, b is 1 here, k is 2. So first of all, let's use the formula. Later on, I'll be specifying the values of r and phi. So I'm going to get r1 raised to n, 2 raised to x, isn't it? K raised to x, cos of bx plus c. So here x plus n phi. So phi here going to become n phi 1. That's the formula for the first term. Then you have minus 1 by 16 with the second term. That's a constant. Then r2 raised to n. Again you have 2 raised to x cos of 5x plus n times of phi 2. So we will specify the values of r2 and phi 2 in a short while. And then minus 1 by 16, you have r3 raised to n, and then 2 raised to x cos of 3x plus n phi 3. So you now need to tell the values of r1 phi 1, r2 phi 2, and r3 phi 3. So let's first of all get the value of r1. It is going to be under root of, you remember the formula, isn't it? It is log k the whole square plus b square. So k is 2 everywhere. K is 2 everywhere. So I get log 2 the whole square plus, students, I have b square. So the value of b is 1 here. So I get 1 square, which is 1. And I should be telling the value of phi 1 also. It is tan inverse of, it is b upon log k. So b is 1 upon log of k, which is 2. You should be clearly, very clearly remembering the formulas, the place of a, the place of b, the place of k. Everything should be crystal clear in the mind. So only then you will be able to write the answers very quickly. So that was r1 and phi 1. Now let's write the value of r2 and phi 2, students. So r2 is going to be under root of, again this first term is going to be same, log of k square plus b square. For this term the value of b is 5. So I get 5 square, which is going to be 25. I'm going to use values directly now, and then you can write phi 2. It is going to be tan inverse of b upon log k. So b is 5, students. This was b square. So b is 5 upon, you have log 2. So that is the second term phi 2. And finally I'm going to get the last term, which is r3 and phi 3. So r3 is going to be under root of, you get log 2 the whole square plus, what's b for the last term? It is 3, isn't it? 3 it is. So 3 square is going to happen. That's going to be 9. And let's quickly write phi 3. It is going to be tan inverse of b upon log k. b is 3 log k, k is 2. So students, this is how you should be presenting your solution. So far, what types of questions we have learned? We have learned questions in which trigonometric terms were involved, isn't it? Sine bx plus c, cos bx plus c, then exponential and trigonometric, e raised to ax sine bx plus c, e raised to ax cos bx plus c. Likewise, we have seen this last type where it was k raised to x into sine bx plus c and k raised to x into cos of bx plus c. So we have seen all these formulas and how to apply them while solving the questions. And have you realized that the application of the formula is just one step? What is more important is knowing your trigonometry very properly. So students, that was all about this particular types of questions. We have seen questions based on method of partial fraction and questions based on trigonometric terms. Now we are going to proceed ahead with the next very important part of the chapter, which is called as Leibniz theorem. So students, let's proceed ahead with the next concept, the Leibniz theorem.